A lot of time the last couple days finding the side lengths. Like if we knew something about the angles, then we could use sine, cosine, or tangent to find those trig relationships to figure out what missing sides are. If we knew like at least one of we knew the angles inside the triangle and maybe one of the sides. So we're going to start here by kind of a quick review, and then once we know something about the side lengths, we're going to actually kind of hopefully be able to work backwards with these trig functions and come up with, say, angle measures if we know the side lengths. Okay. So for example, find the sine, cosine, and tangent of angle A, just as a review from yesterday. For angle A here, let's find its sine, cosine, and tangent. Angle A is here, and the side lengths are 8, 15, and 17 of this right triangle. So what's the sine of angle A? Sine, if in our mnemonic we had yesterday, SOHCAHTOA, sine is opposite over hypotenuse. So opposite over hypotenuse, 8 over 17. Cosine is the middle part of that mnemonic, which was CAH. Cosine adjacent over hypotenuse. And tangent was the last one, TOA. TOA. Opposite over adjacent. Okay. We have 3 different ratios that describe this one angle. But unfortunately, we don't know what the angle measure is off the top of our head. We know the ratios. We know these ratios built by this angle measure. We don't actually know what this angle measure is we plug in. Shouldn't it make sense that we should be able to find it? If we have these 3 nice relationships, I mean, we should be able, if we know that no matter what the angle is, that we have these ratios of side lengths, it should make sense that you should be able to go backwards. And if you know the ratio, then we should be able to figure out what angle it was that is making up this, what angle is being formed here in this right triangle. At least I hope it makes sense. But it should be a possibility. Okay? And today we're actually going to figure out how to do that. And it's called using inverse functions. Anyone ever used an inverse function before? Heard what an inverse function? You guarantee you've seen and used at least one function and its inverse before. They're called inverse functions. The inverse function on your calculator, the symbol for inverse is like a -1 power of an exponent. So like the inverse of sine is called sine inverse of something. So if we use this inverse sine of the trig ratio that we get, then that'll actually plop out the angle measure that we use. More specifically, let's say we look at our first example up here. If we could use the inverse function of sine and applied it to this ratio, we'd get whatever was inside. And lo and behold, your calculators, graph calculators specifically, have an inverse function for each sine, cosine, and tangent. So by doing, therefore, if I do inverse sine of 8 over 17, I get what angle A is, which we said in our calculators was, what was it, about 28.07, was it? Yeah. About 28.07 degrees. Notice you only need to do this once. We didn't need to do it for all 3 because it's the same darn thing. Because we saw as well that cos inverse 15 over 17 I'll give you the same value for A. That's good. But we'll take the inverse function, plug in the ratio of the sides that we have, and that will pop out the angle measure. Now, as I said the other day, that it's probably even more important right now to make sure your calculator is in degree mode and not radian mode. So if your calculator is in radian mode, then the angle you get out will be measured in what's called radians, which is cool if you know radians. If you don't know radians, then it's going to be kind of ugly, because 360 degrees all the way around a circle once is equal to 2 pi, which is about 6.24. 6.28, actually. So like if you get an angle measure that's like 0.3, who knows if that's degrees or radians, unless you know in mode. Make sure your calculator is in the correct mode. Most of you, it should already be in degree mode, doesn't just switch. But if you're using one of mine, make sure you switch it to degree mode. Oh man, where is this? Change this example to B, because we just did A 3 different ways. Find the measure of angle B 3 different ways, if you would. Find the measure of angle B 3 different ways, please. Sine inverse of what? Okay, that's one way to calculate this angle measure. What's a second way to calculate this angle measure? Of what? Okay, and what would be a third way we could calculate this angle measure? Maybe someone new. Courtney. Absolutely. These would be 3 different ways to calculate this angle, and each way gives you the same measurement. What is the measurement of angle B? Courtney?
61.92 degrees.
About 61.92, or if you round it to the ones place, 62. Okay, so our goal for today is to take that idea of taking angle measures and taking side lengths and finding angle measures in a right triangle, and to use it to what's called solve a right triangle. Or solving a triangle is simply finding all side lengths and all angle measures. In the triangle. Okay. So if we give you a triangle, with all this stuff we have at this point, we really only need to know, well, if you know 3 parts of a triangle, we can find, of a right triangle, we can find the rest, for sure. May only need, well, yeah, we need 3. We need 3 of the 6 things. There's 3 sides and 3 angles. We need to know, if we can know 3 of them, we can find the other 3. For example, if we have these, what's one strategy for finding, say, the rest of the missing sides? Pythagorean theorem. We always can use that. If you know 2 sides, use Pythagorean theorem and you get the third. Okay, well, how are we going to find these angles?
Oh. Pythagorean theorem.
I don't think we can use Pythagorean theorem to find an angle measure.
Oh, we're finding angles?
Yeah, yes.
Did you say that?
I think I actually did say that. You can find the side length of Pythagorean theorem. How are you going to find the angle measures? How about the inverse trig functions? Just what we did before. Use the inverse trig functions. Okay. So, let's solve. Let's solve a right triangle 2, and then you guys can finish solving the rest. Okay. So we use Pythagorean theorem. We can say 12 squared plus 17 squared is c squared. We call this side c. Use Pythagorean theorem here. 12 squared plus 17 squared is c squared. C has got to be square root of 433, about 20.8. C is approximately 20.8. Once we know the three side lengths, now we got to find angle measures. So let's find, pick one of the missing angles. Which one looks like a good one to find? Which one? Sure, we'll find it. Let's find it. Okay, so what are we going to do to find it? You're going to need to find a trig ratio and probably use that inverse idea. So pick a trig function that you like the most. Pick your favorite trig function. What's your sine? Sure. Sine, opposite over hypotenuse. So we'll go with n. We'll go sine of n. We know sine of angle n is opposite over hypotenuse. 12 over 20.8. So therefore, what's the measure? How would we find the measure of angle n if we know the sine of it? Well?
Multiply the I don't know.
Problem is that we're trying to find n. We're trying to find what's inside the sine function.
Oh, then
Let's use the inverse. So we could say, if we know the sine of the angle is this ratio, the inverse sine of the ratio is the angle measure. So you can do inverse sine of this ratio. Inverse sine of 12 over 20.8 should give us the angle measure for angle n. So inverse sine of 12 divided by 20.8. It's about 35.2. N is 35.2 degrees. So if we know n, can we find angle P? Yeah, what's probably the easiest way to find angle P?
add them and then subtract.
Add them and do 180 minus it. You could also, since this is 90, you could just do 90 minus 35.2 has got to be this one. This is another way to do it. 90 minus that answer. Oops.
Minus what?
Forcing angle P to be 54.7 degrees. This 0.8, excuse me. This right triangle is now solved. It's solved because I know all three side lengths, and I know all three angle measures. Okay? We've solved this right triangle. What if I'm only given one side length? If you're only given one side length, you're going to have to start with the sine, cosine, tangent stuff right off the bat. Because we only know one of the two sides. You can't use Pythagorean theorem unless you know two of the three. We only know one of the three right now. Well, there is something you can find pretty quickly, though, in here before anything else. Andrew? Yeah, you can definitely find the third angle. What's the third angle have to be?
40.
Got to be 40. 40 plus 50 is 90. 90 plus 90 is 180. Okay. So we definitely can find the angle V. Well, we got to find some side lengths. Well, this looks a lot like the stuff we did yesterday. We have some angle measures. We know one of the sides. How about we find, let's find these two things, these two guys. I'll call them A and C because it's a right triangle. Pythagorean theorem sounds fun. Find one of them. Pick an angle and pick your favorite trig ratio that seems to be useful. Let's solve. You like tangent. Okay. So what would be a convenient angle to use tangent to find one of the missing things? If you wanted, you could do tangent of 50 is 21 over A, opposite over adjacent. I think there's a slightly easier algebraic way to set that up, though, using tangent. So if you go with 50s, you'd have tangent of 50 is 21 over A. There's, I think, a quote-unquote a better way to set this up, so you do a little bit less algebra. I mean the other way to do it. What's the tangent of 40 equal to? If we go the tangent of 40, that's still opposite over adjacent. So if we go tangent of the other angle, this actually gets a little bit nicer, gives us the variable up top. So you don't have to multiply both sides by 21. It's supposed to do like 2 steps. If you're good with that, then you're good with that. You don't need to. But this might be a little bit, I think this way is a little bit easier to find what A is. Once you know what A is, then what can we do? Now if you want to use Pythagorean theorem, you use Pythagorean theorem. If you want to use sine or cosine with one of these two angles and one of the appropriate sides, you could do opposite. Say sine of 50 is 21 over C. Or maybe cosine of 50 is A over C. And there's a lot of different ways to solve. Just pick one that's appropriate and that works. Okay? Find A, get a value. Use this value in conjunction with the side with Pythagorean theorem. Use sine or cosine to find the hypotenuse. There's a lot of ways to go about doing it. Any one of them, they all should give you the same answer within minimal rounding error. Okay. 17.6. Use it to find C. Okay. If you want to do a couple more practice problems, they're up here on the front board. I'll leave them up here for a second, and I'll get the homework thrown up in just a minute. But there are a couple more practice problems. If you'd like some extra stuff before you jump into the homework, they're here.